Good afternoon to one and all. I'm R.V. Kiran, Assistant Professor, Department of Mechanical Engineering, Chevrolet Engineering College. So, as the third BTech second sem notification has been come from the university, I'm going to revision the metrology subject, in which this is the first class of this revision for the third BTech second semester students of R16 syllabus. So, I'm going to briefly explain the syllabus, as I have given all the unit materials in the completion of the syllabus. So I have to explain it in the brief way. So first of all, what is meant by metrology? So these metrology terms is derived from the Greek words such as metro means measurement and logy means science. So it is a fulfillment of the study of measurements or science of measurements. So we can derive it from the Greek words. And the BIMP means Bureau of Weights and Measures. So this has embraced that the science of measurement, embracing both experimental and theoretical determinations at any level of uncertainty in any field of science and technology. So these science of measurements can be everywhere in the any field that is of science and technology in both experimental and theoretical determinations. So we have both the determinations in the metrology subject. So first of all, we are going to satisfy it in the theoretical determination, and then we are going for the experimental way. So what is the standards and what are the accuracy and what are the fits, tolerances. So these are all comes under the measurements only. So the science of measurements deals with the both determinations, that is experimental as well as theoretical determinations. So that is we can determine it in the any field, that is science and technology. Next, we are going to see the functions of metrology. So first is the establishing units of measurements. So what are the units in the measurements and what are the inputs we are going to give in that measurement, and establishing the standards in the units of measurements. So where we are using these measurements, what are the purpose of using these measurements. So that is the establishing units of measurement. Next one is the reproducing these units as standards. So by replacing the standards, the units with the standards, that is primary standard, secondary standard. So we have different types of standards there, working standards. So we are reproducing these units as the standards. Next, it also ensures the uniformity of measurement. So there we can ensure the uniformity in the measurements. So uniformity means the parallel errors or unparalleled errors in the units of measurement. So there we can use it in the uniformity. Next, development of the method of measurement. So what are the methods we are going to use in the measurement, and what are the developments we have to take in the methods of measurements. So these are depending upon the measurements we have been taken. The last one is the analysis of accuracy of methods related to the errors. So when we have a method, we are going to take a measurement, and what are the accuracy of taking the measurement in the method. So we are also analyzing the accuracy in the method related to the errors. So if you have taken the measurement, you will get an error with the minimal code. And if I am going to take the measurement, I am going to have an error with different code. So that is the analysis of accuracy of methods related to the errors. So these are all the different types of functions of metrology. Next, sizes and measurements. So what are the units and what are the standards and what are the uniformity of the measurements which we are going to use in the daily purpose. So in the screen you have seen about the yards and inches. So what are the inches and what are the yards? Inches means angulalu in Telugu. I am going to take it as angulam. So inch ante angulam antaramma. Yard ante gajam antar Telugulo. So yard is meant as gajam in Telugu, and inches means angulam. So there are very varieties of measurements. So tablespoon, cup, pint, quart, gallon, ounce, and pounds. So these are all related to somehow with the length measurement, some with the weight measurements, and some with the liquid measurements also. So what is the first one is the tablespoon. So what is the volume of the tablespoon, or what is the length of the tablespoon, or what is the weight of the tablespoon? So we can use it in different method measurements. So what is the weight and what is the length? What is the thickness of the tablespoon? Next, coming to the cup, what is the volume of the cup? So what are the volume, that is what is the limit of the cup to be filled with? Next, we are going to gallons. Gallons means it is a form of water or any liquid. We are measuring with the gallons or liters. So that is the measurement of the liquid form. And next one is the ounce and pounds. So these are these are all in the weight measurements. So ounce, pounds, kgs. So these are all in the weight measurements. So the inches and yards comes under the length measurement. So that is called as end measurements also. And measurements also. So these standards of measurements can be with several standards. First one you can see in the second picture, which is 1 foot, 2 foot, and imperial yard. So these are all the different standards. Coming to the sizes and measurements. So these are all the ortho wedge, heel wedge, and slimline wedge. So these are all the different standards. So coming to the first standard, that is XS. So that is X small. That is next one is the small and medium, large, and extra large. So these are all the different standards of the measurement. So these are all the different standards of uniformity of measurements. Next we go to the measurements. So methods of measurements. So there are different methods of measurement as we have taken from the scale and other and see here are the some of the length measurements. So we are all know that 1000 millimeters is equal to 1 meter. That is 1000 millimeters, 1000 is equal to 1 meter. Next, 250 millimeters is equal to quarter part of the meter. So these are all the substandard. And 10 millimeter is equal to 1 centimeter. So we all know that in this scale there are 10 divisions for each centimeter, and the divisions is called as millimeter. That is 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. So for the 10th division, we get a number that is 1, 2, 3, 4, 5, 6. So these are all the centimeters which is indicated in the numbers. And next, 100 centimeters is equal to 1 meter, and 50 centimeters is equal to half meter. So these are all the length standards which you have seen in the scale or tape. So this is the steel rule which we have seen in a daily wise measurement. So these again, one side of the scale is measured with the centimeters and other side is with the inches. So the and when we are going to measure the, we have a good accuracy on it. So we have to measure it with good accuracy. So when the accuracy is not in the measurement leads to the failure of the measurement. So that is called in the picture. Next, we are going to the objectives of metrology. So what are the different objectives? So these are highly used for the selection of proper measuring instruments, and these are used for deciding the proper measuring standards. So first of all, selection of proper measuring instruments. So when you have to measure yards, so when you have to measure yards, there is no purpose of taking it from a scale. So we are taking it from a yard tape or any other measurement. So that is the selection of proper measuring instrument. Next, deciding the proper measuring standard. So for length or any other standard, we have to decide the proper measuring standard. So that is the basic objective. Next one is the use for minimizing cost of inspection. So when we have decided to take a measurement and going for the inspection, we have to minimize the cost for the inspection purpose. That leads to the minimal manufacturing cost of a product. Next one is the determining process capabilities. So we have to process the determine the processing capabilities of a measurement, and next decide or find the tolerances. Next, achieve the standardization. So next one is the achieve standard, and next one maintain accuracy and precision at the time of inspection. So at the time of inspection, you have to decide that. Last one, maintain accuracy and precision at the time of inspection. we have to maintain the accuracy and precise measurements have been taken at the time of inspection. So that is the main objectives of the metrology. And next one, types of metrology. So there are mainly two types. First one is the legal metrology. We can take it as scientific metrology also. Second one is the deterministic metrology or industrial metrology. So these are the two types of metrology. In that, first one is the legal metrology or scientific metrology. So it is the scientific or fundamental metrology that concerns with the establishment of quantity system, unit of measurement, and the development of new methods, etc. So this develops the quality of the measurements, and the development of new methods will bring on to the quality of the measurements also. So it leads to the quality and quantity of the system. And the next applications for the legal metrology are: first one is the commercial transactions related with net quantity, and second one industrial measurements, accuracy and interchangeability. Third one is the measurement of health, and last one is the measurement of human safety. So these are all the different applications which we are used to in the legal metrology. Next one is the industrial metrology. So this industrial metrology concerns with the application of measurement science to manufacturing and other process, and their use in the society also. So it concerns with the application of measurement science to manufacturing and process, and their use it in the society. So here in the picture you can see the digital vernier calipers. So this is the latest edition on the vernier calipers. In the olden days, we have seen about the manual vernier calipers, and nowadays it is in the digital form. So when you see the, or when you touch the end standards, that is of the both ends in the vernier calipers, the reading has been shown in the screen. But in the earlier days, in the olden days, in the manual vernier calipers, we have to measure the measurement. So that is also an advanced version in these vernier calipers. to save the time and to save the manual power and to reduce the manufacturing lead time. So these are the latest additions in it. So these are possible in the applications of industrial metrology, in which the measurement science to manufacturing and other process, and they are used in the industrial purpose and in the society also. Next one is the inspection. So in engineering activities, inspection involves the measurements, tests, and gauges applied to the certain characteristics in regard to an object or activity. So, inspection plays a very vital role in the careful observation of a designed project or manufactured product. So, these inspection plays an important role. So, which is involves the measurements, tests, and gauges applied to certain characteristics. The next one is the what is the need of this inspection. So, what is the purpose of doing these inspection activities after producing or manufacturing this product? So, the need is first one is the quality output. So, the quality has been checked in the inspection. So, what is the grade of quality in the product have been produced? Next one is the changing technology. So, what are the advanced technology used in the production? The next one is the mass production. So, in the mass production, the number of products have been produced in a single variety. So, only one type of design have been there for all the products. They are manufactured in the continuous production. So, the mass production is done in the continuous way. So in the mass production also you need to achieve these inspection techniques. And next one is the to save money. So when there is an error in the product, it should not be refunded or released from the manufacturer or customer. So that is why we are going to do the inspection before going to the market, before the product is sent to the market. That is going to save money also. Next, interchangeability. So when there is an error in the product, we are going to interchange it with the other product. So that is the mean by the interchangeability. Next one, to develop the reputation. So nowadays all the toys or any other um, the kids playing items have been come from the China only. So the product is the standard is came from the China and they are making it as made in China. So this product is a made in China or this product is a made in Japan. But our country cannot produce in this type of quality items or complex shapes. So the design also is very important in this picture. So to develop the reputation, so what are the standards they have maintaining, and so what are the different types of methodologies they have been implementing in that process. So that also we have to develop and to develop the reputation also. These are also of one kind. Next, different standards of measurement. So a standard is an exact quantity that people agree to use for comparison. So we are going to compare it with the other. So if we are going to a shop and buy a 1 kg standard unit, so that you have to see the meter or measurement satisfies the exact quantity of the product. So we have to see, oh, it is 1 kg or it is 2 kg or it is 3 kg. So that is defined by the standard of an exact quantity. So that defines by the exact quantity that people agree to use for comparison. So in these days now we are going it with the digital meters only, digital measurements only we are taking it in. So these digital standards have been taken for the accuracy. So in some areas or in some shops or other areas, so the standards have been very poor. So they used to change the exact quantity. So if it is 1 kg, they are going to set it with the 850 grams or 900 grams. So the change is in the digital meters only. But in the olden days, the exact quantity of the measurements have been produced very accurately. That is the main difference. So next one is the types of standards. So what are the different types of standards we are going to use it? So first one is the primary standard, second one secondary standard, third one tertiary standard, and last one is the working standard. So these are the different types of standards that we are going to implement. So these are the different types of standards. So first one primary, secondary, tertiary, and working standard. So let's go to the first one, that is primary standard. So they are the material standard preserved under most careful conditions. So most careful conditions, you have to preserve the material standard. So they have been preserved in that way. And these are not used for the directly for measurements, but are used once in 10 or 20 years for calibrating the secondary standards. So what do you mean by calibration? Calibration means what are the standards set up by the secondary standards. So what are the different types of calibrations? So these calibrations comes under the different standards. Next last one is the international prototype meter imperial standard. So these are all the imperial standard yards. Hello, నమస్తే తిరుమల ఎఫ్ఎంహెచ్ అమ్మా ఎన్నిటికి తిరుమల 5 to 6 అర్థం కాలేదు తెలుగులో. మామూలుగా అంటే R16 అబ్బాయి, R16 4 యూనిట్లు చదువుతాంగా. ఈవినింగ్ రమ్మంటే వస్తా. అదే మొన్న ఎవరో డామ్ కూడా So, and the example for the primary standards is international prototype meter or imperial standard yard. So international prototype meter అంటే మీటర్ అమ్మ మనకి. ఒక మీటర్ ని ఇంటర్నేషనల్ ప్రోటోటైప్ మీటర్ అంటారు. నెక్స్ట్ ఇంపీరియల్ స్టాండర్డ్ యార్డ్. యార్డ్ అంటే గజం, ఇందాక చెప్పాను కదా, యార్డ్ అంట. సో దీస్ ఆర్ ది టూ ఎగ్జాంపుల్స్, బెస్ట్ ఎగ్జాంపుల్స్ ఫర్ ది ప్రైమరీ స్టాండర్డ్స్. First one is the international prototype meter. So you can see it in the picture. So these are the prototype meters used in the earlier stages of the measurements. So this is a meter which is calculated, and these are in the British standard. So British Museum lo undamma manaki ippudu kuda. So the bars were to be made of a special alloy. So these are made with the special alloy, and it is 90% platinum and 10% iridium. So this is an alloy. So alloy ante meeku telusu kadamma, two or more metals combined to form an alloy. So which each majority a metal. So platinum is a metal and iridium is also a metal. So 90% platinum we are taking, and then remaining 10% we are going into the iridium structure, which is significantly harder than the pure platinum. So which is very significant than the pure platinum, and have a special X-shaped cross section that is called as Tresca section. So the X cross section ni manam Tresca section antunamma, named after French engineer Henry Tresca. So this is named after the French scientist Henry Tresca to minimize the effects of torsional strain during the length comparisons. So ఈ బార్ యూజ్ చేస్తున్నామో మనకి టెంపరేచర్ నుంచి కానీ ప్రెషర్ నుంచి కానీ స్టాండర్డైజ్ గా యూజ్ చేసుకోవచ్చు మనకి. సో అందుకని ఈ బార్ ని 90% ప్లాటినం అండ్ 10% ఇరిడియం తో యూజ్ చేశారు. ద లెంత్ ఆఫ్ ది prototype meter is shown in the figure also. That is 100 centimeters, and length is 20 centimeters, and width is also 20 centimeters. So these are all the with the international prototype meter, which defines the length standard, and it is an example for the primary standard also. Next one is the international prototype weight. We have to define the weight also with respect to the length. So the IPK is made of a platinum alloy, so which is known as platinum 10 LR, that is NIR, platinum with 10% iridium. So the same alloy used for the length standard, which is 90% platinum and 10% iridium, and is machined into a right circular cylinder, which is the height is equal to the diameter of the shape, which is of 39.17 millimeters to minimize its surface area. So which is of the its surface area. So that is the specific weight of the prototype weight, which is in the international prototype weight. Next one is the secondary standard. So the value of the secondary standard quantity is less accurate than the primary standard one, and generally it is obtained by the comparing with the primary standard. So when we are going to use it a second standard, it is going to be a secondary standard. So the first one we are using it is the primary standards, and it is with the secondary standard only. So the value of the secondary standard quantity is less accurate than the primary standard one, and it is obtained by the comparing with the primary standard. These are all the close copies of primary standard with respect to the design, material and length. That is called as prototypes. Prototypes are similar copies. So these are all the close copies of primary standards with respect to the design, material and length. So when we are coming with the design and material, or when we are getting into the length also, these are very close copies with the primary standards. So that is about the secondary standard. Next one is the tertiary standard. So this tertiary standard is maintained in the NPL. NPL means National Physics Laboratory, which is situated in Delhi. So this is maintained in the National Physics Laboratory only. So this is for the government purpose or research purpose only. Research purpose in the measurement standards, that is called National Physics Laboratory, and shortly we known as NPL. The primary or secondary standards exists as the ultimate controls, which is for the reference at rare intervals. So these are going to be referred at the rare intervals only, and they are made as close copies of secondary standards and are kept as reference for the comparison with working standards also. So these are also made for the close copies of secondary standards and are kept as reference for the comparison with working standards also. So these are all made with the references and comparisons. So these are with the tertiary standard, and last one is the working standard. So these standards are similar in design to the primary, secondary and tertiary standards, but being less in cost are made of very low grade materials, and these are used for the general applications in metrology laboratories. So these are used for the general applications in metrology laboratories. So these are all with the working standards. And next, coming to the line standard. So the standard in which the distance is measured with the two parallel and straight lines. So when we are going to measure it with the straight lines or parallel lines, this is with the line standards only. Then the example is steel rule. So the daily used steel rule is the best example for the line standards, and the advantages are quick and easy to measure, and they are cheaper. So they are cheaper than the other one. And the disadvantages are parallax error can be generated and accuracy is very less. So the accuracy used in this line standard is also very less. So that are the disadvantages for the line standards. And end standards, so the other standards can be discussed in the next class. We are going to discuss it with the next class only. Thank you.